Now, the general solution of a second-order differential equation is a linear combination of two linearly independent solutions. Okay? So this is a second-order differential equation. That means the highest derivative is the second derivative, right? When we're solving it, basically what we're doing is we're integrating twice to get the function, to get back the function, right? So if you integrate twice, you get two integration constants. And so we can if let's say f1 is a solution and f2 is a solution, then you can say the general solution f is going to be c1 f1 plus c2 f2, a linear combination, provided your f1 and f2 are linearly independent. What do we mean by linearly independent? f1 cannot be equal to just some constant times f2. That's what linearly independent means, right? So like, for example, sine x and cosine x, are those linearly independent? Can I write sine x as just some constant times cosine x? No, so those are linearly independent. But what about negative sine x? Sine of negative x. Is sine x and sine of negative x linearly independent? They're not independent, right? But what is sine of negative x? So sine of x, negative sine of x is just a constant times sine x. See? They're not linearly independent. So you have to find, in other words, to get the general solution of a second-order differential equation, you have to find two linearly independent solutions and take a linear combination of the two. All right, so earlier, what did we say are two specific solutions, linearly independent solutions? E to the s1x, the same problem we had earlier, right? And so our two possible solutions are e to the 1/2 x and e to the negative 1/2 x. So those two are linearly independent solutions. Okay, so e to the 1/2 x and e to the negative 1/2 x. Each one of these, if you plug it in, it gives you the right answer, right? It satisfies the equation. The general solution would be c1 e to the 1/2 x plus c2, c1 and c2 are constant, e to the negative 1/2 x. That would be the general solution. Let's verify that that is in fact the general solution. What would you do? You plug that in, right? So what is y prime? c1, what's the derivative of e to the 1/2 x? E to the 1/2 x plus c2 negative 1/2 times e to the negative 1/2 x. So that's your y prime. What's your y double prime? c1 1/2 squared, right, was 1/4, e to the 1/2 x, and c2 negative 1/2 squared, so that's 1/4, e to the negative 1/2 x. So what was our equation? Our differential equation was 4y double prime minus y, right? So 4y double prime minus y equals 4 times c1 times 1/4 e to the 1/2 x plus c2 times 1/4 e to the negative 1/2 x. That's your 4y double prime. Minus y, which is c1 e to the 1/2 x plus c2 e to the 1/2 x. Is that correct? What is, so I can factor out this 1/4, right? And cancel out the 4. And what happens? That whole thing is just equal to 0, right? And which is what we want, 4y double prime minus y. Okay? Each one of these solutions, you plug it in, it will satisfy this differential equation. The linear combination of the two also satisfies the differential equation. So this is what you would call your general solution. Okay? The general solution is a linear combination. Okay. Differential equation. Huh? This is an example of a differential equation. Equation that has derivatives. Your goal when you solve a differential equation to get the function. See, this is a differential equation. 4 times the second derivative of y with respect to x minus y equal to 0. This is an equation that has a derivative of y in it. The second derivative. So your goal in a differential equation is to solve for y, the function. If there's a derivative in your equation and you want to solve for the function, that's called a differential equation. Okay? All right. How about this one? What's the general solution for this? Okay, so let's just, this is the same type, right? A_y double prime plus b_y prime plus c_y equal to 0. So what's our A? 4. What is our B? 0. What's our C? So what are our two possible values of S? So our solutions would be e to the sx, right? S would be negative 0 again, plus or minus square root of 0 squared minus 4 times 4 times 1, 4ac over 2 times a, so 2 times 4. So that's going to be equal to this plus or minus square root of negative 16 over a. What's the square root of negative 16? 4i. Okay, so that's plus or minus 4i. I is square root of negative 1, right? Over 8, so plus or minus I over 2. So what's our general solution? Constant times e to the I x over 2, right? Plus c2 times e to the negative I x over 2. That's your general solution. Got it?